Okay, so hi everyone, this is third lecture of linear algebra course by Dr. Dilip Patil. So we'll start with the first problem today, that is problem 1, uh, which says that compute the solution set L of epsilon A and determine all A of R uh, so that the following system of linear equations with coefficients in R epsilon A, which is which consists of three equations. This uh, x plus ay plus z equals to 1 and x plus y plus az equals to 1 has 1 no solution, 2 exactly one solution, and 3 which says more than one solution. So I suggest you to take 5 minutes and read this problem, then you can start maybe 2-3 minutes, that way you can familiarize. Okay, so let us first try to rewrite the solution set in adjugate matrix form, and the matrix form of this system is 2 1 1, so bar 1, then 1 a 1, so bar 1 1 1 a 1. So there are three elimination problems methods. So first what we do is that interchange row 1 and with row 2, then we write second row in the first row, that is 1 a 1 1, and write second row as the first row, 2 1 1 1, and 1 1 a 1. Then what you see is that so our first a column and first row entry, it is 1. So you can say the first target is obtained. Then second method, what we will do is that we will replace R2 with R2 minus 2R1, and we will replace R3 with R3 minus R1. This way you keep your first row as it is, 1A1 1, and the second row will be 0, 1 minus 2A minus 1, 0, 1 minus A minus 1, and it will be minus 1 and 0, right? So the last row is 1 minus A to Y minus Z is to 0. Now obviously you can see that since there is only one variable here, there are few cases to follow. So the case 1, the case A equals to 1 will be something like this. The three equations, become 2x plus y plus z equals to 1, and x plus y plus z equals to 1, and subtracting x equals to 0, and then y plus z equals to 1. Hence what you get is the solution set as L of epsilon of 1 is 0, t 1 minus t, where your t belongs to R, right? And since t is a variable, so therefore it is infinite. Now we move to our second case, that is case A not equals to 1. Divide R3 by 1 minus A not equals to 0 to get 0, 1, minus 1, 0, that is y equals to z, and interchange it with R2. That way we will see that we get 1, 0, 0, A, 1, 1 minus 2A, and 1 minus 1 minus 1, and you will see 1, 0 and minus 1. That way it will give you R3 to R3 minus 1 minus 2A of R2. Okay, so that way we will get 1 a 1 0 1 minus 1 0 0 minus 2a with 1 0 minus 1. So there are two subcases to follow, that is a equals to 0. There the last row is 0 sorry 0 0 0 minus 1. So you can see that this system will say that 0 equals to minus 1. Therefore L epsilon 0 equals to 5. That means no solution, right? And for the second subcase where a not equals to 0, we'll see that back substitution gives z equals to 1 by 2a, then y equals to z equals to 1 by 2a, then x equals to 1 minus ay minus z equals to 1 minus a plus 1 by 2a equals to a minus 1 by 2. So every variable is leading. So this is a unique solution where L of epsilon of a equals to a minus 1 by 2a, 1 by 2a and 1 by 2a, right? So our answer will be in this form if we write it clearly. A equals to 0 gives us no solution. A does not belongs to 0, 1 gives us exactly one solution, and the third one a equals to 1 says more than one solution, right? So this completes our first problem. Now we go to our second problem. Problem 2. Let K be an arbitrary field. Compute the solution set L epsilon A comma B comma C and determine all A comma B and C of K so that the following system of linear equations is consistent. Which is epsilon A comma B comma C and x plus 2y minus 3z equals to a 2x plus 6y minus 11z equals to b and x minus 2y plus 7z equals to c. So I suggest you to try this for 10 minutes, then we will start discussing this. Okay, so let us start solving this. Uh, so first again, let us write this system in a algebraic matrix, that is 1 2 minus 3 of A, and then 2 6 minus 11 as B, and 1 minus 2 7 as C. So this will give us R2 changing into R2 minus 2R1, and R3 changing into R3 minus R1 will give us 1 2 minus 3 0 2 minus 5 and 0 minus 4 at 10, and it will be A, B minus 2A and C minus A. So then changing into this R3 with R3 plus 2R2 will give us 1 2 minus 3 0 2 minus 5 0 0 0, and here it will be A, B minus 2A, 2B plus C minus 5A. Now all these steps are valid for over any field. So I mean, you can clearly see that epsilon A comma B comma C is consistent if and only if 5A minus 2B minus C equals to 0, that is C equals to 5A minus 2. So in order to show that, in order to prove further that in order to determine all A, B and C, we have to assume that this system is consistent. So from now on, assume C equals to 5A minus 2. Now we'll try to solve two cases when characteristic of K not equals to 2. Then the middle row has pivot 2 not equals to 0 in the second column. So X, Y are leading and Z is free. Now put Z equals to T. Now from the second row, 2y equals to b minus 2a plus 5t, that is y equals to b minus 2a plus 5t by 2. And from the first row, x equals to a minus 2y plus 3t equals to a minus b minus 2a plus 5t plus 3t equals to 3a minus b minus 2t. Hence, L of epsilon a b 5a minus 2b equals to 3a minus b minus 2t, b minus 2a plus 5t by 2, comma t, where t belongs to k, is the solution set. Now check for t equals to 0. There x equals to 3a minus b, y equals to b minus 2a by 2, then x plus 2y minus 3z equals to 3a minus b plus b minus 2a equals to a, and 2x plus and where was I? 2x plus 6y minus 11z will be 2 into 3a minus b plus 3 into b minus 2a, which equals it will be 6a minus 2b, and it will be 3b minus 6a. So both the 6a get cancelled and it will be b. And similarly for the third case, you will see that x minus 2y plus 7z will be 3a minus b minus b minus 2a, which equals to it will be 3a minus b, and it will be minus b, and it will be 2a, so 5a minus 2b. And from the first equation you can see that your 5a minus 2b is c. So our characteristic k not equals to 2 case is done. Now we'll come to characteristic k equals to 2. Okay, so in this case here you know that our 2 is considered as 0, minus 3 as 1, minus 11 as 1. So this is a binary number system, minus 2 as 0, where your all even numbers we will consider as 0 and all the odd numbers will be considered as 1. So the system this one actually reads something like this. Itself reads as x plus z equals to a, z equals to b, and x plus z as c, and our consistency notation and consistency uh, notation reads as uh, yeah, it says 5a minus 2b minus c equals to 0, which becomes, since 2 is 0, a minus c is to 0, that is a equals to c. Now so what does this imply? That now x, z are leading and y is free. Therefore your solution set will be epsilon a comma b comma c. These are the form a plus b t b, where t belongs to k. So we are done. So this was your problem number 3.2 in the assignment practice sheet. Now we will come to our third problem, problem number 3. Let K be a field with characteristic of K not equals to 2, and let A belongs to K. We have to compute the solution set of the following system of linear equations over K. The system is x1 plus x2 plus x3 is 1, x1 plus ax2 plus x3 as 1, x1 plus x2 plus x3 is 1, and x1 plus x2 minus x3 is 1, 2x1 plus 3x2 plus x3 is 3, and x1 plus x2 plus 3x3 as 2. So I suggest you to try for 5 minutes, then we can begin our discussion. so let us start solving. So there are two systems. Let us first work with the first system, that is this one. I will copy it. Okay. So this is our first system. Now, first we take the adjugate matrix 1 A 1 1 1 1 A, and on the right side it will be 1 1 1. So now we will apply the elementary row operation as R2 changed by R2 minus A R1 and R3 changed by R3 minus R1. So now the first one is fixed 1 1. Now let's see what happens on the second. The second one, it will be R2 being replaced by R2 minus AR1, so A minus A would be 0. So it will be 1 minus A square, and the third one will be 1 minus A, and on the right hand side it will be 1 minus A. And R3 will be replaced by R3 minus R1, so it will be 0, 1 minus A minus 1 and 0. So again there are many cases to follow. So the first case is case A equals to 1. So what happens that when A equals to 1, you see that the last row becomes 0 0 0, so obviously the equation is consistent, and the second row also becomes 0 0 0 0. So all, and the first row becomes 1 1 1 1. So what we will get is all these equations coincide, that is your x1 plus x2 plus x3 equals to 1, and then the solution will be 1 minus s minus t comma s comma t will be s t belongs to k, a two parameter family, so it will have more than one solution. Now we will have another case, that is case A not equals to 1. There divide R2 and R3 by 1 minus A not equals to 0, and interchange the resulting rows. Which is, again, the first one is will be fixed 1a1 1. The second one, if you divide it by 1 minus a, it will be 0, 1 minus 1 0, and the third one will be 0, 1 plus a 1 and 1. and now you uh, interchange by 0, uh, R3 being replaced by R3 minus 1 plus A of R2, and then you will have 1 A1 1 0 1 minus 1 by 0 and 0 0 A plus 2 by 1. So this will be our system, and now there are two subcases. If A plus 2 not sorry if A plus 2 not equals to 0, then back substitution gives x3 equals to 1 by A plus 2 and x2 equals to x3 and x1 equals to 1 minus ax2 minus x3, which will give us 1 minus a by a plus 2 minus 1 by a plus 2. So it will be 1 minus a plus 1 by a plus 2, which will give us I think it will be 1 by a plus 2, yeah. So then every variable is leading, and therefore there is a unique solution which will be L equals to by a plus 2 1 by a plus 2 1 by a plus 2. And there is another subcase. If a plus 2 equals to 0 and what we assumed a not equals to 1, then the last row is zero 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 1. So L equals to 5, right? And so yeah, so your L will be empty, and yeah, and therefore more or less we are done. So there is another system of equation here, which again we have to solve, and let us do it. So it is our second system. So now take again the adjuvant matrix as 1 1 minus 1 1 2 3 a as 3 1 a 3 is 2. And now if you change it with r2 going to r2 minus 2r1 and r3 as r3 minus r1, then you will have 1 1 minus 1 and 1. The first row is unchanged. Now for the second it will be 0 1 a plus 2, right? And for the it will be 1, yeah. And for the third row it will be changed as 0 a minus 1, it will be 4 and 1, yeah. Now the third process will be you change your r3 with r3 minus a minus 1 r2, and it will give you 1 1 minus 1 1. The first one is fixed and the second one will be 0. Also the second one also will be fixed 1 and a plus 2 1, but the third one will change. So the first one will be, third one will be 0, and you subtract a minus 1 minus a minus 1, so it will be 0, and it will be 4 so it will be 4 minus a minus 1 into a plus 2, right? So which is, if you calculate, will be a plus 3 into 2 minus a, and this one here it will be 1 minus a minus 1, so it will be 2 minus a. Apologies for the conjunction. So yeah, now okay, let me write it clearly. I think it will be better. 1 1 minus 1 1, then 0 1 a plus 2 1, 0 0 a plus 3 into 2 minus a into minus a. Okay. Now alright, so yeah, again there are several subcases to follow. That is, the subcase number 1 is, what if a not equals to 2 and a not equals to minus 3. So what I am trying to gain is that to make them invertible, to make them non-zero numbers, then what happens is that then a plus 3 into 2 minus a is non-zero, and all variables are leading, and back substitution gives x3 equals to 2 minus a by a plus 3 into 2 minus a, which equals to 1 by a plus 3. Then x2 equals to 1 minus a plus 2 to x3 minus a plus 2 by a plus 3, which is 1 by a plus 3. Then what happens is that you just put these values into x1 equals to 1 minus x2 plus x3, and I'll skip the calculation, but after a but yeah, x2 and x3 both are equal, so they will get cancelled and you will get 1. Alright? Yeah. So what we'll have is that the solution as 1 comma 1 by a plus 3 comma 1 by a plus 3. So the solution is unique. Now we have the second case, second sub case, which is a equals to 2. In this case, if you look at this matrix, if a equals to 2, then this one will be 0 and also this one will be 0. So the last row will be entirely 0. So the system will be consistent at least. So let me write it. The last row becomes 0, sorry. So the last row becomes 0, 0, 0. And your x3 t is free, and your x2 is 1 minus 40, and your x1 is 1 minus x2 plus x3 equals to 5t. Therefore, in this case your solution set is 5t comma 1 minus 4t comma t, and t comes from k. So it will have more than one solution. So we are done. Oh sorry, there is another sub case also, I forgot. A minus 3 and a not equals to 2. But in this case you can see the last row is of this form, 0, 0, 0, 2 minus a. So it will be 0, 0, 0, minus 5. So inconsistent. Inconsistent. Yeah. So we are done. Now let us go to our next problem. Yes. Problem number 4, I guess. Let A belongs to R and let epsilon of A as x plus y minus z equals to 1, 2x plus 3y plus 2az equals to 3, and x plus 2ay plus 3z equals to 2. So determine that, find for which values of A A has no solution, uh, exactly one solution, and more than one solution. Okay, I suggest you to try this for 10 minutes because I have been doing these kind of problems the entire session, so it will be best for you to try yourself. Okay, so let us write the adjugate matrix first. So the matrix is, I guess, let me check it once again. Yeah, I guess this is, yeah. So it would be 1 1 minus 1 1 2 3 2a as 3 and 1 2a 3a is 2, and then if you replace your R2 by R2 minus 2R1 and replace your R3 by R3 minus R1, we'll get 1 1 minus 1 1 and 0 1 2a plus 2 is 1 0 2a minus 1 4 is 1, and then for the third one you'll get if you replace your R3 with R3 minus 2a minus 1 R2, then you will have the first row is unchanged, minus 1 1. The second row becomes, after a quick calculation, 0 1 0 1 2a plus 2 1, and the third row becomes 0 0 2 into 2a plus 3 into 1 minus a. It will be 2 into 1 minus a, right? So now for when the system will have no solution, so if 2a plus 3 equals to 0, then you will have a equals to minus 3 by 2. Then 1 minus a becomes 1 minus minus 3 by 2 becomes 2. Therefore, the last row is 0 0 0 2, so no solution. Now the second and third maybe I will put as exercise exactly one solution. A does not belongs to 1 comma minus 3 by 2, and the third one is more than one solution as a equals to 1. You can try this yourself. Okay, so let us move on to our last problem for today, problem 5. Let one second. Okay. let A as your matrix, 2 x x x x 8 7 x be a 3 cross 3 matrix of R. Uh, find at least 3 real numbers x such that the linear system of 3 equations in 3 variables ax equals to 0 has infinitely many solutions. So again I suggest you to try this for 10 minutes. Then Okay, so let us start this solution. So since we have taken ax equals to 0, L, which is a solution space of ax, A is a subspace of R3, right? We have seen this in the previous class. So it is infinite exactly when it contains a non-zero vector V. So it suffices to exhibit for each value of x one non-zero solution. So suppose x equals to 0, the first subcase, then our matrix will be of this form. A would be 2 0 0 0 0 0 and 8 7 0, and A 0 0 1 T, that is transpose, is 0 0 0 transpose. So L has 0 0 1 2, that T belongs to R. Maybe I should write it as capital T. Now the second subcase is x equal to 2, and then your A is 2 2 2 2 2 2 8 7 2, and A of -5 -6 1 of T is 10 minus 12 plus 2, 10 minus 12 plus 2, and the third case is 40 minus 42 plus 2. So it is again 0 0 0. So L is infinite. Now we have the third case, that is x equals to 7, then A equals to 2 2 2 2 2 2 8 7 2, and A of 5 minus 6 of 1. So check it yourself. 0, 0, 0. So no, it should be 0, 1 minus 1. So L is infinite. Thus x equals to 0 to 7 are such real numbers. So we're done. Okay, so thanks everyone for joining. We'll finish here today. We'll meet in the next class.
Matt, Tom, namaste.
Thank you.
Namaste.
How is a Christopher Nolan production like The Odyssey unique from an actor's perspective?
Where to begin?
Yeah, I mean,
Whatever world you enter in the morning that you're shooting in is an immersive world because Chris captures everything in camera. If you see 1,000 people in a battle, there are 1,000 people there.
What was the toughest day on set?
well, you have to answer that one.
I can't answer it. We've been asked that question and it just makes me laugh because there was not an easy day on this movie.
When I was watching the movie yesterday, I couldn't help but wonder, there's this text I've been reading, it's a Sanskrit text, and there's a verse in it. It says, Yatra Vishwam Bhavatya Ekanidam. And what it means is that the world itself becomes a nest, and home is actually inside of it. And I think that's kind of what Odysseus is realizing.
Yeah.
What do you think of that?
No, I think that's very true. I mean, I think for me, home is my family, though that is something that I carry inside me wherever I am. But I do know what you're saying. The experience remains the same, and who you are and what you make of it is really down to you.
Welcome back to PGX, where you get smarter, explore new ideas and watch raw and real conversations. If you're enjoying the show,
How is a Christopher Nolan production like The Odyssey unique from an actor's perspective?
Where to begin?
Yeah, I mean, how much time do we have?
Well, okay, so your day would start, say we were shooting in Favignana, the day starts with a hike. So you've got to get to the top of the mountain where you're shooting. And so the whole crew hikes the mountain. Sometimes if there's a helicopter that's shuttling things up, some equipment, and sometimes you can get a ride on those. Some crew members who were unable to make that walk would get a lift in the morning. Sometimes if you were lucky as an actor and they really needed you on set, you would get the ride.